Hey everyone! In the previous video we talked about atomic mass, and today we'll do some exam questions to consolidate our knowledge. So last time we discovered that the term atomic mass, which from a language perspective implies the mass of a single atom, is actually the average mass of all the stable isotopes of the element.
What?
Why would chemists not make it more obvious and call it something that will simply describe what it is? For example, the average mass or the mean mass? Well, to confuse the hell out of you. To calculate this atomic mass, aka the average mass of an atom of an element, we would look at all the stable atoms that an element can have. In other words, all stable isotopes. Then, see how common each of them is, i.e. look at the abundance of each one, and plug this all into the formula. Let me show you how it's done. Neon contains 90.48% of neon 20, 0.27% of neon 21, and 9.25% of neon 22. Let's find out its relative atomic mass. If you are an experienced learner, you would know that the most difficult part is rewriting all the information from the question without making any mistakes. Now that it is done, it's time to summon the formula. This ancient artifact suggests that we should multiply all isotopic masses by their abundance. So let's do that. We will multiply 20 by 90.48, 21 by 0.27 and 22 by 9.25. Then all this mass will be divided by 100 to get 20.1877, which is 20.1 to three significant figures. Easy, right? You just plug in the numbers into the formula. So let's do a harder example. But first, have you noticed how all abundances add up to 100? This is a fact that you need to remember. The total abundance of all the stable isotopes of the element is always 100%. And in the next few questions, we'll have to use this fact in order to calculate the unknown abundance, or form another equation. Okay, now you're ready to tackle the second question. Try it yourself and only then watch the solution. So, as before, rewrite everything without mistakes. However, we completely don't know one of the isotopes. Not a problem, let's denote its isotopic mass with X and its abundance with Y. Since percentages add up to 100, we can write the following equation, and so the Y drops out to be 14.3. Now it's the same as before, plugging in the numbers into the formula. 83 times 3.39, 84 times 82.3, and x times 14.3. After that, it's all divided by 100, which is equal to the AR. To get rid of the fraction, we will multiply both sides by 100, which will give us this. Then 281.37 and 6913.2 on the left hand side will add up to 7194.57, which we can then subtract from both sides and get this. After that, we will find out that x is equal to 85. That was a bit more interesting, so let's move on to an even harder question. Try this one yourself as well. Pause the video, cause here is already the answer. Okay, so as usual, let's rewrite all the information we were given. And since we don't know the abundances of E26 and E27, let's denote them as X and Y. We have two unknowns, so we will have to form two equations. You can start by writing an equation for abundances, as we did before. But I will start by creating an equation from the formula instead. It doesn't really matter which one you do first. Abracadabra, and the formula appears. So let's plug in even more numbers. 26 times x plus 27 times y. then divide by 100 and make it equal to the AR. After tidying everything up, our equation will transform into this. Now it's time to use the abundances to form another equation. Since we know that they must add up to 100%, x plus y should be equal to 100. And in the end, we'll get a pair of simultaneous equations which can be solved by substituting one into the other. Since we need to find x, the percentage of E26, let's make y the subject of the formula, and then substitute it into the second equation. After expanding brackets, you'll end up with this, which then tidies up to give us 70%. Applause to everyone who did it right, or who is just still here. You are legends. Alright, that's it from me. Thanks for watching, and I will see you in the next video.